Unit 6, Lesson 4, Applying Properties of Definite Integrals. In this section, we move beyond finite sums and explore what happens in the limit as the terms become infinitely many small and the number of rectangles approaches infinity. We will look at some geometric functions that may contain negative values, meaning below the x-axis, as well as positive values above the x-axis and 0. At times, we will integrate functions that go below the x-axis. Here are a few pointers for when that happens. Area below the x-axis counts as negative area. The total area between A and B for some curve is really a net area, where the total area below the x-axis is subtracted from the total area above the x-axis. Leibniz, who was a famous mathematician, introduced the notation for the definite integral. The Greek letters of summation become Roman letters in the limit. The notation summation or integral from a to b f of x dx is read as the definite integral from a to b of f of x with respect to x. So that is how we read that. Now, I want to remind you that if you just see this and a function without any numbers on the top and the bottom of my little s there, that is called an indefinite integral. Okay, that is an indefinite integral. The answer to an indefinite integral is a function. If you see your integration sign with a number on the bottom and a number on the top, this is a definite integral. And your answer will be a number. And that number is the area under the curve. Okay, so answer will be a number. So if there's more area below the x-axis, your answer might be negative. Okay, so and it will make more sense as we keep going. So let's just keep going here. I just wanted to kind of point out they're talking about something called a definite integral, and it's just basically the integral of a function with a number on top and a number on bottom. So now, here are the component parts. I'm going to start with the a. That is my lower limit. Of course, this summation sign, it's not a summation sign, but we said it looked like an elongated S. That is my integral. And the b is my upper limit. F of x is called the integrand. And you're thinking of it as the derivative function. When you see an integral, you should think of it as that function that you're looking at is the derivative, and your answer is going to be the original function. dx here is the variable of integration. So that's what you're integrating with respect to. So the variable of integration is x for this one. It could have dy, it could have dt, so if it had dy, your variable of integration would be y. If it had dt, your variable of integration would be t. And this whole thing is the definite integral. And we said that we knew it was a definite integral because it was going from A to B. If it didn't have the upper and lower limit, then it would have been an indefinite integral. So the definite integral can be used to determine the net area or displacement bounded by the x-axis the function f of x and the vertical lines x equals a and x equals b. Okay, so it definitely is the area under the curve, or between the curve and the x-axis. So example number 1, use the graph below to evaluate each of the following. Note that the graph of f of x consists entirely of line segments and a semicircle on the interval -8 to 13. So part A, the integral from 0 to 7 f of x dx. So what we're going to do is we're going to think about, here's my 0, right? And here is 7. So we're talking about all of this area. It's all positive because it's all above the x-axis. It is a trapezoid, so I could use my area of a trapezoid to figure out the area, or I could split this up into a triangle, a rectangle, and a triangle. Okay, so either way you would like to do that. I split it up into a triangle, a rectangle, and a triangle. I went ahead down below and I said, okay, for the first one, it's 1/2. My base is 2. My height is 4, so 1/2 of 8 would be 4. And then plus my rectangle, it looks like it's 1, 2, 3 by 1, 2, 3, 4. So a 3 by 4 gives me an area of 12 plus, and then I have another triangle, 1/2, my base is 2, my height is 4, so 1/2 of 8 is 4. So when I add this up, I get a total of 20 for part A. For part B, I'm going from 0 to 13. Now I already know what 0 to 7 is, right? And I know that my integral from 0 to 13 can be looked at as my integral from 0 to 7 plus my integral from 7 to 13. So I'm going to use that, and I'm going to say, okay, I know 0 to 7 is 20 plus, and then when I look at my integral from 7 to 13, all of that is below the x-axis. So that whole thing's going to be negative when I figure that out. And again, if I wanted to split this up into a triangle, a rectangle, and a triangle, I could kind of over here, let's just do it right here, I could figure out what that negative area is. So I know I'm going to be adding negative area, right? But let's go ahead and just add the area. We've got 1/2. And then the base of our triangle is 1. The height is 3 plus, and then we've got a 3 by 3 rectangle. And then we've got a 1/2, base of 2, height of 3. Remember, when you're doing that one, just, figure out what it is. And when you're taking the area of a triangle, you're not going to say it's, like a -3. You're going to just say, hey, that's the area of my triangle. It's below the x-axis. That's why I wanted you to kind of keep it separate with that negative on the outside. I want you to look at that area as positive. So that's going to be 3 halves plus 9 plus, and then this one's just going to be 3. And so this is going to be 3 halves plus 12. And since my 12 is actually 24 halves, I have 3 halves plus 24 halves is 27 halves. So I'm going to be subtracting 27 halves, or plus a negative 27 halves. 27 halves is 13 and a half, right? I don't know if you want to look at it like that. You can look at it as 40 halves minus 27 halves. That would give me 13 halves, and it would be positive. And 13 halves, I'd say, or 6.5. So 13 halves, or if you wanted to do 6.5, you could have done that. But you had to notice that that was below the x-axis, so it's going to be negative area. Okay, so for part C, negative 6 to 0 is what we're looking at. So from negative 6 to 0, we are looking at this area right here. We know it's going to be negative because it's completely below the x-axis, and we're going to notice that it is a half circle. So to calculate that, I'm going to say 1/2 pi r squared, right? Because it's half of the area of that circle. And the circle has a radius. If I notice that this is my center, it has a radius of 1, 2, 3. So that would be 1/2 pi 3 squared. So that's going to be 9 pi over 2. So this is going to be negative 9 pi over 2. Because it's below the x-axis, the entire thing, we knew that the entire thing was going to be negative. And that's the answer to your integral. Part D, the integral from 3 to 3, f of x dx. Well, I'm not going anywhere, right? 3 to 3, guess what? I get 0. The integral from 7 to 0. If you're going backwards like that, you remember me saying that the lower limit has to be less than the upper limit? So I have to take the negative of the integral from 0 to 7, and we already figured out what the integral from 0 to 7 was. We knew it was 20. So this is going to be negative 20. Integral from 10 to 4, f of x dx. Well, the bottom is not smaller, so you have to say the negative of the integral from 4 to 10, f of x dx. Okay, so now let's look at what we have there. So I'm going to do it in a different color. Oops. So from 4 to 10, so we're talking about, oh gosh, starting here and ending here. So we knew right here that this was 4, right? That triangle. This is 1 times 4. So this is going to also be 4. So that total is going to be 8, right? We said if you look right here, this is a really fat color, isn't it? That is your 1/2, 2 times 4. That's that triangle. And then you've got your 1 by 4 rectangle. So that's 8. This one, our first triangle, we said, I think we did that one over here, was 3 halves. Okay? So I know, oops, sorry. I know that that right there is 3 halves. That's that little triangle. And then we have a 2 by 3. So that one is 6. So for this one, it's going to be a positive 8. I'm going to get out of that really fat one. Positive 8. And remember, this negative's on the outside. Positive 8 and a negative, and we're going to go ahead and add that 3 halves plus 6. But that whole thing's going to be negative, right? So negative on the outside of 8 minus, this is going to be 12 plus 3 is 15 halves. So 8 minus 15 halves, which is negative 16 halves minus 15 halves. So that negative 1/2 for F. And I hope that made sense. Okay. Integral from negative 8 to 13. So that's going to take us all the way across. The only one that we haven't done yet is this. And this one would be 1/2. My base is 2. My height is 4. So this is 4. So let's go ahead and think about this. We'd have a positive 4. We have a negative 9 pi over 2. We have a positive 20, because that was our 0 to 7. And we have a negative, our 7 to 13. Where was that? Our 7 to 13 was negative 27 halves. So if we add all those up, our positives give us 24. If we combine our negatives, you can't really combine that because one of them has pi. But we can combine these two. So 48 halves minus 27 halves is 21 halves minus 9 pi over 2. And that is the best you can get there, because you can't combine those. Now, what would the derivative be of f at negative 6? So if I look at negative 6 and see that this is like a cusp, my derivative would be undefined, because there is a cusp. Cusp at x equals negative 6. So undefined would be my answer. If I took the second derivative there, what would my answer be? Well, or actually, that's not negative 6, I was going to say. At positive 6, look at this. If I took the second derivative at positive 6, my first derivative is going to be the slope of this line. So it looks like it has a slope of negative 2 over positive 1. So my first derivative at 6 would be negative 2. But my second derivative, is it concave up or concave down? It's neither. So my second derivative is going to be 0. If it was concave up, it would be, my second derivative would be positive. If it was concave down, my second derivative would be negative. But since it does not have concavity at all, my second derivative is 0. Okay, so no concavity at x equals 6. So my second derivative is 0. The average rate of change in f over the integral from 0 to 5. So that average rate of change is f of 5 minus f of 0 divided by 5 minus 0. So what is my f of 5? Well, if I come up here and 4, 5, my f of 5 is 4. My f of 0 is 0 divided by 5 minus 0. So my average rate of change over that interval is 4/5. Letter K, true or false? Okay, so let's think about this. The integral from 0 to 2, okay, which we said was 4 here, plus the integral from 2 to 4, okay, which we didn't really figure that out, but let's say 2 times 4, this is 8, is equal to the integral from 0 to 4. Well, that is true. I went from 0 to 2, and then I added from 2 to 4, and that gave me from 0 to 4. That's true. Over which value or values of x is f of x not differentiable? Well, we said that it was not differentiable at x equals negative 6 because there was a cusp. Okay, then at x equals 0, you also have a cusp. okay, because it goes from being like that circle to a straight line. At x equals 2, you have a corner. At x equals 5, you have a corner. At x equals 7, you have some sort of corner. It goes from one slope to a different slope. At x equals 8, you have a corner. At x equals 11, you have a corner. Okay, so those are all the ones, and we're not going to talk about our endpoints there. We're just going to look at those in between values. Okay. Now we're going to start talking about some properties. And the definition of the definite integral of f on the interval on the closed interval AB specifies that a has to be less than b. Now, however, it is convenient to extend the definition to cover cases in which a equals b or a is greater than b. And we've already talked about this, but it's nice to have this confirmation of a formula, property, or rule. So number 1, if f is defined at x equals a, then the integral from a to a, f of x dx is 0. I told you that. We've already talked about it. Here's your official definition. Number 2, if f is integrable on the closed interval ab, then the integral from b to a, f of x dx, is the negative of the integral from a to b, f of x dx. Again, we've talked about that already, but now you have an official definition. Number 3, if f is integrable on the 3 closed intervals determined by a, b, and c, then the integral from a to b, f of x dx, is equal to the integral from a to c, f of x dx, plus the integral from c to b, f of x dx. Okay? So, and we would think that c would be in between a and b there. So properties of definite integrals. If f and g are integrable on the closed interval ab and k is a constant, then, so look, if you have a constant that's being multiplied by a function and you're taking the integral, you can pull that constant out and then just focus on taking the integral from a to b and then multiply it by that constant. That was number 4. Number 5, the integral from a to b k dx is going to be k times b minus a. And I can explain that one a little bit better because remember, k is a constant. So if I said that we have the integral from 1 to 2 of, let's say 5 dx, okay? Then your constant, what you want to be thinking of is, oh, well, that 5 is y equals 5. That's y equals 5. And if I want to integrate it from 1 to 2, I'm just talking about this area right here. And so can you see why that this would be equivalent to 5 times 2 minus 1. I was going to put b minus a, but I already gave you a b and an a. So 5 times b minus a. So 5 times 2 minus 1. Well, that makes sense because look, it would be the length of my rectangle is 1 and the height is 5. So length times width, or the width is 5. Length times width, that would give me my area. So that's like my length times width here, where this is my length and this is my width. Okay, so that makes sense. And we are going to look at if this is my derivative, then my capital F is going to be 5x from 1 to 2 is going to be how I technically am going to look at that. The integral of 5 dx is 5x from, which is just like a vertical line, we say from 1 to 2. And the fundamental theorem of calculus tells us that this is equivalent to 5 times 2 minus 5 times 1. So that also would give us that 5, okay? So we're going to, this is where we're going with this, and you'll see it coming up soon. The next one, number 6, the integral from a to b of f of x plus or minus g of x. That means you've got two different functions being added, dx, and you can split them up. The integral from a to b of just f of x plus or minus the integral from a to b of g of x. So let's try an example. So example number 2, use the properties of integrals to evaluate each of the following, given that, so they're giving us the fact that the integral from a to b f of x dx is 8, the integral from a to b g of x dx is negative 3, and the integral from a to b h of x dx is 5/2. So we've got three different functions here, f of x, g of x, and h of x. So we have to pay attention to what we're doing here. So we've got the integral from b to a, g of x dx. Well, that's the negative of the integral from a to b, g of x dx. So here's that one. We know that that is the negative of, well, they told us it was negative 3. So this one simplifies to positive 3, minus a minus 3. This one, you can see how it has a constant that we can pull out in front. So 2 times the integral from a to b f of x dx. So 2 times, and we said that this was 8. So this one is going to simplify to 16. 2 times 8. The integral from a to b of 5 dx. Oops, that's the that was the example that I gave you. So this is going to be 5 times the quantity b minus a. And if you want to simplify it to 5b minus 5a, that's fine also. Okay, so either this answer is fine or 5b minus 5a. Distributing that. Integral from a to b of 5 plus g of x dx. So we can split this up because these are like two functions. Integral from a to b of 5 dx plus the integral from a to b of g of x dx. Notice that this was not multiplication there. If it were 5 times gx, we would have brought the 5 in front. But this was 5 plus gx, so we broke it up into two separate integrals. So we said that that first one was 5 times b minus a, and then plus our second one we said was negative 3. It gave it to us up here. So that's plus negative 3. And I'm just going to leave it like that. You really can't simplify it. All right. E, the integral from a to b of f of x minus h of x dx. Again, we can split this up into two separate integrals. The integral from a to b of f of x minus the integral from a to b of h of x. And we said that the f of x one was 8 minus our h of x one is 5/2. So that's like 16/2 minus 5/2. So that is 11/2 as my answer. And then f, we have the integral from a to 4 h of x dx plus the integral from 4 to b h of x dx. So this one, it's almost like, pretend like your a was 1 and your b was 7 or something like that. And let's say this is my h of x, okay? This is my h of x. So what they're saying is that, hey, if I broke this up at 4, right? Here's my integral from 1 to 4. Here's my integral from 4 to 7. That's going to be equivalent to my integral from 1 to 7, right? So here, this is going to be equivalent to my integral from a to b. And that one, they told us, was 5/2. So that is our answer for that one. Okay. Example number 3. Find the following if the integral from 1 to 5 of 3 times f of x plus 4 dx equals 34. Find the integral from 1 to 5 f of x dx. So this is kind of like a puzzle, and we're going to start this puzzle first by breaking this up into two integrals with that plus sign. So I know that this is the integral from 1 to 5 of 3 f of x dx plus the integral from 1 to 5 of 4 dx, right? And then we've got the equals 34, okay? I know I can split that up into two separate integrals. Now, on this one, this first one, I can pull the 3 out front. And on this one, I can say that it is 4 times 5 minus 1, because that's the integral of a constant. And we said that that would be equivalent to 4 times b minus a. So now we've got 3 times the integral from 1 to 5 f of x dx, and I'm going to say that 5 minus 1 is 4. 4 times 4 is 16. And then I'm going to subtract 16 from both sides. (34 minus 16 is 18. I am now going to divide by 3 on both sides. And I see that my integral is equivalent to 6. So that was kind of a puzzle, kind of fun. I like that one. Example number 4, even and odd functions. Consider if f of x is an even function, where the integral from 0 to 3 f of x dx equals 8, then what is the value of the integral from negative 3 to 3 f of x dx? Well, think about what an even function looks like. It is symmetric about the y-axis. Think about your even functions. One even function is cosine would be an even function. X squared, right? Y equals x squared is an even function. So, you know, any of them that you could, and I'll show you cosine. Remember what the definition is. If I gave you an x and we found the y, if it was an even function and I gave you the exact negative of that x, it's going to give you the same exact y. That is your even function because it is symmetrical about the y-axis. So if I gave you an x and you found it on your function, and I gave you the negative of that x, it should be in the exact same y value for your function if it's even. So therefore, if I integrated from 0 to 3, it should be the same as integrating from negative 3 to 0. So my integration from negative 3 to 3, f of x dx, should be equivalent to the integration from negative 3 to 0 of f of x dx plus the integration from 0 to 3 f of x dx. But if it's even, these are going to be the exact same thing. So this is going to be like 8 plus 8 for this problem. So this is going to be 16. And then if it's an odd function, I don't know if you remember odd. So these were both even. And if we thought about odd functions, something like, oops, that was supposed to go through 0, 0. Like x cubed is an odd function. Oops, odd. Where if I put an x in and I get a y, if I put the exact negative of the x, I get the exact negative of the y. Okay? It is symmetrical about the origin. So for that one, if the integral from 0 to 3 was -8, then what would the value of -3 to 3 be? Well, for that one, it would be the exact negative. So if I had this area here, this area over here would be the exact negative of it. So if this was +8, this would be -8. So if I went and integrated the whole thing, I'd have 0, right? So this one's going to be 0 because my integral from -3 to 3, oh my goodness, this is fat, of my f of x dx is equivalent to -3 to 0 plus 0 to 3. But if it was odd, and we knew that this was 8, this one would have to be -8. Okay? And that's how I got my answer of 0 there. All right. So now, in some cases, a definite integral can be evaluated by using geometry. Sketch the region defined by the definite integral. Then evaluate each integral using a geometric formula. So sometimes, like if we draw this, so if I draw this and I know that 1, 2, 3, it goes through the y-axis at 3, it has a slope of 1. So, you know, you're just drawing your linear function here. And you want to calculate it from 1 to 4. So you would be talking about this area right here. Okay, this is a trapezoid. They're saying you're going to use a geometric formula to find that area under the curve, because we know that the integral from 1 to 4 of x plus 3 is the area under the curve of this linear function. We know this is a trapezoid. This is a trapezoid, right? And look, here is the height of your trapezoid, which would be 4 minus 1, which would be 3, right? That's the height of your trapezoid. And your base 1 is here. This is base 1. And it would just be the function's value at 1. So you'd put it into your function, 1 plus 3. So that's going to be 4. And this is base 2. And it's your function's value at 4. 4 plus 3, that was going to be 7. Right? So this one was at the point 1, 4. This one was at the point 4, comma 7. And so to calculate this, area of a trapezoid, height divided by 2 times base 1 plus base 2. So we've got our height, which was 4 minus 1, divided by 2, times our base 1 was 4, plus our base 2 was 7. So we have 3 halves times 11, giving us 33 halves. So 33 halves is your integral. You could go and make sure that you got it correct on your calculator. I showed you how to do that on Desmos, I think, so you could go and check that. All right, now this one is a little bit more difficult because you're probably thinking, I don't know what that is, but you actually do know what this is. If I had a circle, the equation of a circle is x squared plus y squared equals r squared if it was centered at 0, 0, right? And so let's say r is 2. It would be x squared plus y squared equals 4, okay, if r is 2. If I wanted to try and trick my calculator and put this in, because right now this circle with a radius of 2 is not a function. It fails the vertical line test, but I can trick my calculator. I can solve for y plus or minus the square root of 4 minus x squared, and I can look at it as the top function, which would be the one that we're looking at here. This is going to be y equals the square root of 4 minus x squared. And that's the top of it, and the bottom of it is the negative one. And so, I don't know what, my pen's getting ready to go out, guys. I'm sorry. Now I'm having trouble writing with it. Y, and that was part of my equal sign. So it's not negative. There we go. So I want just the top one, because look what I'm integrating. I'm integrating just this top portion of this circle. Okay, and I know that this is -2 and this is +2. Because of that 4 right there, I know that that's the case. And look, I'm integrating from -2 to +2. So that means I want the area under this curve. Well, that's a half circle. So see how they wanted you to use a geometric formula? And I know that the area of a half circle is 1/2 pi r squared. So if I wanted to find the answer to this integral, I'm just going to say 1/2 pi 2 squared. So this would be 1/2 times 4 pi, or 2 pi. So that integral's answer, if you put that in your calculator, it's going to give you 6.28 something something something, which is equivalent to 2 pi. Okay, so now part C. We're almost there. We've got the absolute value of x plus 3. Well, I know that that would be 1, 2, 3. This function, which is the absolute value function, shifted up 3 units. Now they want me to find the area from -2 to 4. Okay, so that means that we are trying to find the area of this trapezoid plus the area of that trapezoid. And if we find those areas and add them together, we've got the answer to the integral from -2 to 4 of the absolute value of x plus 3. So hopefully that looked familiar to you, I hope. So we're going to say, okay, let's figure out what the area of this trapezoid is, and of course reminding ourselves that the area of the trapezoid is height divided by 2 times base 1 plus base 2. And of course this would be my height of my first one, so that would be 2. So my height of my first one would be 2 divided by 2 times my base 1 would be the y value for here. Right? If I put -2 in, I get 5, because I take the absolute value of it. +2 plus 3 is 5. So base 1 is 5 plus my base 2. If I put 0 in, I get 3. Plus, and then now I've got this other one. This is my height. This is going to be 1, 2, 3, 4. 4 divided by 2 times. My base 1 is 3. It's the same as my base 2 of the other one. My base 2 is my function's value at 4. So 4 plus 3, 7. So this is going to be 8 plus 2 times 10. 28 is my answer to C. Okay, letter D. Cube root of x. Now, you might not remember what the cube root of x looks like. If you don't, go ahead and get your calculator out and look to see what that function looks like. I'm looking for you to draw a picture of it, though, so please make sure that you're not just getting your calculator out to put this into your calculator, because we're going to be using a geometric formula to find the answer to this integral. You can check your work using your calculator like that, but I don't want you to use it. So now, there is a vertical tangent right here. This goes absolutely straight up and down right at 0. Okay, so this is what your cube root function looks like. It has a vertical tangent at 0. And so it gets really straight. It goes absolutely straight, right at 0. Straight up and down, vertically. So -4 to +4. Okay? What do you think is going to happen? If I was trying to calculate that area. I hope you're going to say that it's 0, because this is an odd function, and whatever I get here, this one's going to completely cancel it out. So that's all you need to know, okay? At this point, I'll show you how to integrate that later. Right now, we're just doing it geometrically. All right, so the next one, 3x plus 2. That's easy. Goes through it, +2, and then it has a slope of 1, 2, 3, 1, 1, 2, 3, 1. So I'm going to connect. So there's my function, my linear function. I'm going to go from 1, 2, 3, 4. Oh boy. I'm going to have to go the way I've drawn mine. It's taken me all the way into that other picture, or that other problem. So again, we have a trapezoid. If it's a linear function and you're taking the integral, it's either going to be a triangle, a rectangle, or trapezoid. So kind of easy. But we have a trapezoid. So we're going to say that the height of our trapezoid is 4 minus 1, which is 3. So I've got 3 halves times, because this is height divided by 2. Now I need my base 1. So my function's value at 1, 3 times 1 is 3 plus 2 is 5. And then plus my function's value at 4. So again, I would take 3 times 4, 12, plus 2, 14. So I have 3 halves times 19, 57 halves is my answer to that integral. 57 halves. Okay. F, the integral from 0 to 2 of 1 plus the square root of 4 minus x squared. Well, I'm going to tell you that I'm probably going to break this up into the integral from 0 to 2 of 1 dx plus the integral from 0 to 2 of square root of 4 minus x squared dx. Okay, I'm okay with doing that, right? This is going to be 1 times 2 minus 0 plus, and this is going to be, now if you remember correctly, this was, the half circle, right? But this time we're only going from 0 to 2. So this is going to be 1/4 pi r squared. Okay? It's only a fourth of it from 0 to 2. And then plus here, the integral from 2 to 5, 3 minus x. I'm going to go ahead and draw that. 1, 2, 3, and it's negative slope. And I'm going to go ahead and extend that. It would cross here at 3, right? And so if I'm going from 2 to 5, I know that's not perfect, guys, but that's basically what it's going to look like. We are talking about this positive area, this negative. So to figure out what that integral is from 2 to 5, 3 minus x, we've got our 1/2 base of 1, height. If I put a 2 in, 3 minus 2 is 1, height of 1. So this area is 1/2, a positive 1/2. This one, we've got 1/2. My base is 5 minus 3, so that's 2. My height is going to be right here, because look, that's my base, 5 minus 3, my height here, well, what would I get if I put a 5 in? 3 minus 5, I would get negative 2, but I'm just going to do 2. Even though it's negative, I like to, you know, just figure out the area of that triangle is going to be 2. And then I'd say, okay, this is going to be 1/2 minus 2, right? I'm going to put a minus in front of it because I know it's underneath the x-axis. All right, so now, go back to my, this is going to be 2 plus, this is going to be pi because the 4's will cancel. And this is going to be 1/2 minus 4/2. So this is going to be negative 3/2. And so I'm going to add my like terms here and here. And my 4/2 minus 3/2 is going to be 1/2 plus pi.